Hello and welcome to another Big Science. I must apologise first of all for the quality of the audio. Unfortunately the tablet is still charging, so I can't use the tablet as a recording device, and I'm having to use the trolley microphone on the back of that camera. Now I'm going to talk today about something which is on the IGCSE AQA syllabus for chemistry, which is the fluoridation of water. Now I realise this is a controversial subject, so I'm going to talk about that later, but I'm going to raise it as a question rather than actually take a position on it. Mohs hardness scale. Mohs hardness scale is a list of 10 minerals, each of which is harder than the previous one, working up to diamond. So that's talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum and diamond. As it happens, because we live in the East Midlands, we have massive chunks of fluorite hanging around, more specifically Blue John, which is unique on this planet almost. I think there's some in China as well, being found in the Peak District and nowhere else. It's called Blue John because it's blue jaune. Now fluorite is number 4 on the hardness scale. Apatite, rather fittingly, is what teeth are made of. This means that in theory I could bite a chunk out of fluorite and that would not damage my teeth, but I'm not going to try it because I'm rather nervous about the idea of doing horrible damage to my teeth for the sake of one video. Fluorite is calcium fluoride. It's a good source of fluorine in the environment. Now of course fluorine is at the top of the halogens here. It's very avidly attracted to things because it has one missing electron. It wants to get here. And it is probably the most reactive of all the elements. As you go down, it becomes less and less reactive. So you've got chlorine is less reactive than fluorine, bromine is less reactive than chlorine, iodine less reactive than bromine, and then you run out of stable elements, so astatine you can't really say much about. So just because it's so reactive, when it combines with other elements it tends to form a very inert substance. Teflon is polytetrafluoroethylene. Now this feels very greasy to me. It's potentially the smoothest solid substance that exists as far as I know, although obviously technological change may mean that there's something smoother than that. So it's a non-stick pan coating, and this is a bit damaged obviously. It's also quite soft, as you can see. And it's also very inert as a compound. So there is a big difference between fluoride, the ion, and fluorine, the element, which is not the ionized form of the atom, where it's going out and looking for other things to combine with and very aggressively combining with things. So just because something is fluoride doesn't mean it's dangerous. I'm not particularly keen on Teflon, but it's sort of quite useful. Most of our stuff is probably Teflon, and actually I think it's quite useful for preparing herbs in it. Fluoride is also present in things that are in the human diet, notably Camellia sinensis tea, which is the tea that most people drink, and also in krill, which is quite a popular thing that's eaten in the Far East. It's a sort of shrimp-like animal. Both of those are high in fluoride. So we do actually, in this country, and in Japan as well actually, have quite a lot of fluoride in our diets on the whole, although obviously not for me because I don't drink tea. But there is a lot of fluoride around, and it's in tea along with aluminium, which is also considered to be questionable by some people. Fluoride also occurs naturally in bottled water and in water from the ground generally. So some tap water naturally has fluoride in it, and it has been found that in the areas where the water is naturally high in fluoride, tooth decay is less likely. Now the reason for this is as follows. If you take the normal stuff that teeth and bones, because it's also bone mineral, and brain sand are made of, that is hydroxyapatite in most cases where the area is low in fluoride in the water. And that's calcium phosphate with hydroxyl group tacked onto it. In fact, it's twice that because the actual unit for the crystal is 2 of those. The difference between that and fluoroapatite is that fluoroapatite has fluorine on it, and that is actually harder than that is. And that means, in theory, that teeth that have fluoride water on them, which is in the saliva and so forth because of the tap water having it in, will be harder because they will have a veneer on the cavity covered in fluoroapatite. So the idea is it slows down tooth decay by doing that. That means it's slightly harder. So taking my scale again, this is not an integral scale, there are things in between, like for example when I was talking about uric acid, that was between 1 and 2. Apatite, when you're converting it to fluoroapatite, you're actually moving up the scale slightly, so you're making it more resistant to damage and tooth decay and so on. You also make it more brittle, and obviously that combination also occurs in the bones as well as in the teeth. And fluorosis is possible because of that, which is the mottling of teeth. Dental fluorosis.